Hi there. Well, we're going to look at exponents, and we're going to talk about sections 10.1 and 10.2. Even though they're separate assignments, we're going to go ahead and talk about both of them. They're very interrelated with each other. All right, when you're dealing with exponents, we have three rules that we use when we're combining exponents. One is for multiplication, one is for division, and one is for a power to a power. And then we're going to talk about, a zero power and negative exponents and things like that. To begin with, we're going to look at our first rule, and that if you are multiplying bases that are the same, when you multiply bases that are the same, you add exponents. So here, if we have x squared, which means we have x times x, that's what the x squared means. X cubed means that we have three x's, x times x times x, three times that we're multiplying together. When you combine these, you get x to the fifth because you've got 1, 2, 3, 4, 5. So when you're multiplying bases that are the same, you add the exponents. That's our first rule. So the rules themselves aren't hard. I mean, you're adding integers. It's just remembering, when do you add, when do you multiply, and when do you subtract? So, and that just comes with practice, knowing those. So if we had another one, let's say we had y to the fifth times y to the sixth. All right, when you're multiplying bases that match, you add the exponents, which means you get y to the 11th. All righty, pretty large number, y to the 11th, depending upon what y is. Y varies. Now, if I had, as an example, x to the fourth times x, it's not x to the fourth. You need to remember that if the exponent is not there, it's actually a 1, which means that x is equal to x to the first. So you can think about having that 1 there. You can actually place the 1 there if that helps. But if there is no exponent, it means that we have x to the first. And we'll talk about that more in section 10.1, which means that if you take x to the fourth times x to the first, you're going to get x to the fifth. So you do need to remember that. It's something simple as x times x. All right. X times x is x squared because we take 1 plus 1. So they do have an exponent, we just don't put it in. And also, we don't put in the numbers in front either. We don't put the ones in, but they're there because remember when we were doing slopes, just kind of, I don't know, just a side note here. Remember that you go to the y-axis on 3, but the slope here is 1. All right, we don't put that in. We know this is linear because the powers are 1. All right, they're not there, so we know that they're a 1. So we just don't put that 1 in there. It's just assumed to be there. All righty, so when the bases are the same, you add exponents. Well, what happens if the bases vary? So in other words, what happens if I had x squared y cubed? We'll use parentheses for multiplication rather than a dot. Xy to the fourth. Okay, what happens if you were multiplying something like this together? Well, you do the bases separately. So in other words, you look at the x's, these bases match. So you'll add their exponents, 2 plus 1. Remember, there's a 1 there. So you just look at the common bases and you add their exponent. And then you go to the y's. 3 plus 4 is 7. So you add exponents on a common base. And in this case, the x's were the same. You added their exponents. 2 plus 1 is 3. The y's are the same, so you add their exponents. 3 plus 4 is 7. All right. Now, here's another one that gives people some problems. And that's if I had 3 squared times 3 to the 10th. All right, what happens if the bases, okay, this is called the base. What if the bases are not a variable? What if they're 3s or they're both 5s? Well, in order to use these rules here, the bases have to be the same. And in this case, they are. They're both a 3. Both the bases are a 3. The exponents, I'm going to add the exponents. Now notice that the bases were an X, so I kept the X. The bases were a Y, so I kept the Y. The bases are a 3, so I keep the 3. And then you add the exponents. 2 plus 10 is 12. So if you are going to add the exponents, you will need to keep the base the same. And the mistake that some people make is they will write a 9 right there. But there's a huge difference between 3 to the 12th and 9 to the 12th. So if you are going to add these exponents, you'll keep the base the same. And what do I mean by if you're going to add the exponents? Well, here, let's try one more of these, and then we'll look at an example where we're not going to add the exponents. Let's take 5 cubed times 5 to the 8th. All right, quite a large number. And again, do not make the mistake of saying, oh, this is 15, because it's not 15. This is 5 cubed represents the number 125, because you take 5 times 5 times 5. That's what that exponent means, 5 times 5 times 5. This is quite a large number because you're taking 5 times 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 5. You're multiplying 5 together 8 times. All right, it's not 40. All right, it's quite a bit larger than that. So that's just something you have to pay attention to and concentrate on, and it comes with a lot of practice. Well, here the bases are the same, so I'm going to keep the base the same. 3 plus 8 gives you 11, so it's 5 to the 11th. And on some of these, we're going to go through the directions. Sometimes you'll leave it as 5 to the 11th, and sometimes they'll actually want you to multiply it out. If it's really large, don't multiply it out. All right. Now, what I was saying earlier is that if the bases are the same, if you are going to add the exponents, then the base stays. Well, what I meant by that is if I had, let's say, 3xy squared times 2xy to the 4th. All right. So I've changed, okay, these numbers in front here, generally call a coefficient. These numbers in front, I'm not going to add their exponents. Well, for one thing, the bases aren't the same. This is a 3 and this is a 2. Excuse me, what I'm going to do instead is I'm actually going to multiply those two together. I'm going to actually take the 3 times the 2. I'm not messing with their exponents. If you do add the exponents, you do keep the base the same. But I'm just going to multiply 3 times 2 and get 6. So if you have numbers in front, you can go ahead and multiply those together, those coefficients, those numbers in front. You could take 3 times 2 and get 6. And then when you start in with the variables, you will be adding exponents if the bases match. Well, in this case, I have these x's right here. 1 plus 1 is 2. All right, so if they're not there, it's a 1, and you add the ones. And then I've got the y, and then 2 plus 4 is 6. All right, now what if I would have had a z in there? And here, let me come up with another one. Here, let's say negative 4xy z cubed times 2x cubed y. All right, let's say I'm multiplying these two together. So I'm going to go ahead and I'm going to multiply these numbers in front, these coefficients in front. I'm going to take a negative 4 times 2. I'm not adding their exponents. I'm not doing something like this. I'm just going to go ahead and multiply them. I have one negative, one is odd, so my answer will be negative 8. When I multiply negative 4 times 2, negative 8. Now I'm going to take my common base here. I've got an x and I have another x. And normally we go in alphabetical order when we do these, when we write them here. You know, if you go out of alphabetical order, it's not necessarily wrong. It's just by convention, we like to see them in alphabetical order. But it's not wrong. X times y is the same as y times x. Just like 3 times 2 is 6. And 2 times 3 is 6. You know, whether you take 3 times 2 or 2 times 3, you're going to get 6. Well, if you take x times y or y times x, you're going to get the same answers. Like I say, it's not wrong. We just like to see them in alphabetical order. All right, let's look here. X to the first, X to the third gives me X to the fourth when I add those exponents together. Y to the first, Y to the first gives me Y squared when I take 1 plus 1. Now the Z, there's nothing to combine the Z with. And so it just stays. You know, it still has to be a part of the answer. It's just that you're not going to combine the exponents on this Z with anything else because there's nothing else to combine it with. All right, that pretty much exhausts the rule for when you're multiplying common bases, you add the exponents. Well, let's look at our next rule. So I'm hoping that that's clear, and we'll practice a few more from the assignment. Let's look at what happens if you're dividing. X to the fifth divided by X cubed. Well, here, X to the fifth, I'm going to go through why we have the answer, and then we'll look at the shortcut. Just like we did with this, sorry, we're going to go back. Sure, you could write them all out and then count them, or just realize, oh, you know, I just add the exponent and I'll get the same answer as if I have 2 of them, I have 3 of them, I've got 1, 2, 3, 4, 5, X to the fifth. Okay, this means the same as this, which means the same as that. Rather than write it out, obviously, we just add exponents, okay, to get a total number of x's. How many total number of x's are you multiplying by? Well, here, x to the fifth, I must like my x to the fifth. X times x times x. Oh, it's not 1, 2, 3, 4, 1 more. Over x cubed means take x times x times x. All right, now we know from previous experience with our division that, or simplifying, these cross off and these reduce and these reduce, all right, to a 1, which means we just have x squared. Because now we're back to our rule on multiplication, is that when you're multiplying common bases, you add exponents. So you get x squared. We have 2 x's left. Another way to come up with x squared, rather than write them out and cancel them, which would take quite a while, especially if you've got, you know, maybe x to the 30th over x squared or something like that, is that you subtract the exponents in division. 5 minus 3 is 2. So there are times when we add the exponents when we're multiplying bases, and there are times when we subtract the exponents when we're dividing. Subtract these here, and you get x squared. And well, we're going to have some other issues here, but for now, we'll practice this idea. All right, let's go to our y's. Let's say we have y to the 7th over y squared. You could write out 7 y's and 2 y's and cancel, or realize that 7 minus 2 is 5, y to the 5th. All right, now, another thing, okay, I subtracted the exponents, but I put the y to the 5th in the numerator. Why did I not put it down here where the y squared was? Well, obviously from this case here, the 2 x's that were left were in the numerator because I had more of them in the numerator to start with. I have more of them in the numerator. I've got 7 of them. So I know I'll be left over with 5 in the numerator. You know, we just don't put it over 1. So what I mean here's another example. Let's say I have a to the 2nd over a to the 6th. All right, in this example, I have more a's in the denominator. All right, I've got 6 of them and I have 2 of them, so that when they do cancel, I will have 4 left over. 6 minus 2 is 4 here. And you do have to put the 1 in there, in the numerator. That would place that a to the 4th. And we'll talk more about this here in a minute. But again, you have to place them where you have more of them. All right, because you have 4 of these a's left over to cancel out. These 2 will cancel out with 2 of those. you have more of them left over in the denominator, so that's where you're going to put them. That's where they belong. That's where they were to begin with. 4 of those are left over here. All right, well, what happens if we have some numbers in front? Because here we have these little coefficients here, so we multiplied them, all right? Or even this idea, you know, let's incorporate some numbers into our idea of division, where we subtract exponents. Well, let's start with maybe 7 to the 8th over 7 to the 1st. Okay, what would this one come down to be? What would this reduce down? And I'm going to leave my answer in exponential form. Exponential form means to write it with exponents, because you could do this on your calculator. You could take 7 to the 8th, and again, we use that caret key, 7 to the 8th. But for some of you, and I suppose some of you may have maybe some key that looks like that or something like that, I don't know. But either way, and then you could take 7 to the 8th divided by 7, but I want to leave it in exponential form, not as a number. So I will subtract the exponents. This is a 1, okay? Remember, that's a 1. So I will have 7, 8 minus 1 is 7. 7 to the 7th power is correct. Just don't put 49. It's 7 times 7 times 7 times 7 times 7 times 7 times 7 is the answer. So it's a, you know, it's a rather large number, 7 to the 7th power. But when the bases are the same, you can subtract exponents. Same as with the multiplication. And you don't change that base. When you're dealing with the exponents, you're not going to change your base. All right. What happens if I have, let's keep it simple, over 3x. All right, let's reduce this rational expression. Rational is our way of saying fraction, a rational expression. So here we want to reduce this. Now we're not dealing with the exponents on like a common base like we were here. These numbers in front, you can reduce them. You can take 12 divided by 3, or reduce the fraction. 3 goes into here once, and 3 goes into here 4 times. So you have a 4 over 1. All right, so again, you can reduce that. 12 over 3 reduces to 4 over 1. Now dealing with our bases, our common base on the x, I know that the x goes in the numerator because I have more of them. And then I take 2 minus 1 is 1. So we end up with just 4x over 1. Pearson may not like this 1. Okay, so this canceled and it leaves you with 1. Okay, that x canceled out. So really, that is probably the answer that they're going to be looking for. So you reduce the numbers in front, and then you reduce these variables that have a common base by subtracting their exponents. And notice here, this one's gone here. And here, like with these, that one reduces here and leaves you with a 4. 6 minus 2 is 4. Ooh, it's a little out of focus. Now, let's go ahead and mix these with some x's and y's and things like that. So let's say I've got 8x cubed y to the 5th over 12xy to the 7th. I'm just going to draw my bar, and I'm going to reduce it, and if I end up with a 1 underneath, I can just get rid of it. Okay, let's look at the 8 and the 12, and we're going to reduce the 8 and the 12, those numbers in front. What goes into both 8 and 12? The largest number that goes into those evenly, and it would be a 4. So we'll divide this by 4 and get 2, and we'll divide this by 4 and get 3. So we have 2/3. All right. So there's these numbers in front here, these coefficients. We just reduce them. But now let's look at our x's. Okay, now I've got x cubed. I've got 3 x's here and 1 here. Well, I know that this guy's going to cancel out totally. So I'll subtract these exponents. 3 minus 1 is 2, and I'm going to put it in the numerator because there's more of them. That's where I'm going to have those 2 are going to be left over. Okay, in the numerator. So those, I reduced those and got x squared. Subtracting exponents, the y's. Well, obviously we have more y's in the denominator. 7 minus 5 is 2. All right. And I reduce those by subtracting their exponents. Okay, so there's our second rule. So in multiplication, we add exponents. In division, we subtract exponents and put them wherever the largest one is. And we're going to come back to this idea here in a minute with negative exponents. All righty, last one, and then we'll look at some special cases that are going to appear in your 10.1. The last one deals with a power to a power. I just feel like this is going to be not focused, but let me. Yep, it's not focused. Awesome. All right, so here we have x cubed quantity squared is how you could read that. X cubed to the second, or x cubed quantity squared. When you have a power to a power, you multiply the exponents, which means we have x to the 6th. So in this case, you're going to multiply the exponents. Now before, I wrote them out. This means we have 2 of these. Okay. All right, that's what that means. I'm taking x cubed times x cubed. I've got 2 of them that I'm multiplying together. And again, when you multiply, you add the exponents. 3 plus 3, and you get 6. So remember that multiplication is fast adding. So rather than add them separately, you can multiply. I have 2 groups of 3. I have these 2 groups of 3. So when you have a power to a power, you multiply. Let's look at some more examples. Let's look at y to the 5th to the 3rd. So I'm taking y to the 5th times y to the 5th times y to the 5th. I have 3 of those is what this means when it's on the outside. I have 3 of these, which means multiplying those, I have y to the 15th. So you multiply when you have a power to a power. Let's try another one. Let's say, I don't think I want, I'll just do a z. Z to the 7th to the 5th. Okay. I have z to the 7th times z to the 7th times z to the 7th, 5 times. Or 7 times 5 is 35. Z to the 35, which is going to be quite a large number depending upon what the z represents. But even if it's a 2 or a 3 or a 4, it gets quite large quite quickly with these exponentials. So I'm writing these in exponential notation, exponential form. I'll go through the your homework and exactly how they'll state that. Looks like they're going to use exponential notation. These are written in exponential notation. They're simplified. All right, what happens if, well, let's look at our numbers. Let's say I have 5 squared to the 8th. Okay, just like before, when you're dealing with the exponents, you'll keep it as a 5, and you'll multiply a power to a power. 5 to the 16th. Big number. All righty. Now let's mix it up. What happens if I have maybe 3x squared cubed? Okay, I have these two things in here. The 3 is being cubed and the x squared is being cubed. Well, I'm going to handle them separately. I'm going to take 3 cubed, but I'm not going to do it like this here. I'm going to actually find the number. What is 3 cubed? So when you have a number in front, if they don't say write the entire thing in exponential notation, you go ahead and find 3 cubed. And it's not 9. 3 times 3 times 3 is 27. And it's not huge, so it can be done. So we cube the 3 because it's in the parentheses. And then here we have an exponent. So when you have a power to a power, you multiply those. And we can practice this idea. 27x to the 6th is your simplified answer. Let's try another one. Let's do 5x cubed y to the 4th squared. Okay. I'm going to go ahead, instead of doing something like this where I have these two exponents that I multiplied, this would be exponential notation, the answer. I'm going to go ahead and take the 5 and square it. You know, it's doable. It's not this huge number that's going to take 16 digits to write. 5 squared is 25. 5 times 5. So because everything in the parentheses is being squared. So 5 times 5 is 25. Then x, I'll take and multiply a power to a power, multiply a power to a power. Oops. All righty. So your answer is 25x to the 6th, y to the 8th. So there are some times where they'll actually want you to find out what that number is to that power there. And if this is kind of confusing, just remember that squared means I'm multiplying 2 of these together. So we have 5x cubed y to the 4th times 5x cubed y to the 4th. These two statements mean the same thing. So if you don't want to use the rule of a power to a power, if you wrote them out, you could just multiply the numbers in front. 5 times 5 is 25. And when you're multiplying, you add exponents. X cubed, x to the 6th. 3 plus 3 is 6. 4 plus 4 is 8. Or using the power rule, you multiply those and then just take 5 squared. This will work. The only problem is if that is to the 12th, you probably don't want to write 12 of those out. So this is just a little faster. Multiplication is fast addition is all it is. All righty. Let's look at, well, all right. That pretty much covers our 3 rules. Now we're going to go back to the subtraction. And we're going to talk about the subtraction because it has some special significance with some of the problems in 10.1. And then we will review some of these. So if it's still a little confusing, don't worry, we're going to keep practicing. All right, I want to look at the division rule. And I know that if I have, let's do our 3 over 3. I seem to default to 3s for some reason, but that's all right. 3 over 3, I know from, the beginning of our block that when you have 3 over 3, you get the number 1. All right. And I also, I need something to keep that. Know that if I have, like 5 over 5 is 1. Well, if you look at the rule that we just talked about in the fact that if the bases are the same in subtraction, or excuse me, when the bases are the same in division, you subtract the exponents. Well, let's change them to x. I know from this that this is equal to 1. But if I subtract the exponents and simplified it that way, I'm going to subtract the exponents. 1 minus 1 is 0, which means that x to the 0 is 1. We know that when these match, our answer is 1. 3 over 3 is 1, 5 over 5 is 1, x over x is 1. But if you use your rules, you get this, which means that by definition here, x to the 0 has to equal 1. All right, so anything to the 0 power, 1 minus 1 gives you 0, is 1. So this is just kind of a proof for you as to why anything to the 0 power is 1. In other words, if I had, let's go to here. I have 3 over 3, which we know is equal to 1. But if we were to subtract the exponents, we keep that common base. 1 minus 1 is 0. You subtract exponents in division. So 3 to the 0 must be 1. Here, 5 over 5. If you're dealing with the exponents, you keep the bases. 1 minus 1 is 0, because you subtract exponents in division. So anything to the 0 power is going to be a 1. And it's just something you can remember. I just thought maybe if you knew why and where we got that idea, it might make it easier to remember that anything to the 0 power is 1. Because when you subtract these exponents, you get a 0. And yet we know from past experience that all of these are equal to 1. Therefore, anything to the 0 power must be equal to 1. And if I gave you, let's see, 7,322. All right. Here, I don't know if that's showing up in there or not. Anything to the 0 power is 1. All right. And so we're going to practice this in 10.1. Anything to the 0 power is 1. And the other thing that they deal with in 10.1 is this idea of going from 3 to 3 to the first. Whenever you have a power of 1, it can be rewritten as this. So you can go from here to here and here to here. They're equal. So looking down, if we have 10, those two mean the exact same thing. They mean the exact same thing. So these are the two ideas that they're going to talk about in 10.1. And 10.2 does the rules, but I wanted you to know the rules so I could explain why x to the 0 is 1 and 3 to the 0 is 1 and 5 to the 0 is 1, because it uses that division rule of subtracting exponents to come up with this. So I thought it would be nice to remember it. So now what we're going to look at, and we might come across some other things that I forgot about, but for now you should have the basics. We're going to look at some of the homework problems from 10.1. Well, this is actually a worksheet. It's not really problems from the exact homework. We can see those, but these won't take you long. 10.1 shouldn't take you too long, because anything to the 0 power is 1. 8 to the 0 is 1. Anything to the first power, can just be rewritten without that 1. Those two mean the same thing. All righty. Then they're going to ask you to evaluate. And the reason why another reason why I wanted to do these is it's a good review for the final that's coming up. So they're going to give you a value for X and ask you to put it in. And this is a good skill, is to be able to evaluate given certain numbers for your variables, to be able to put them into some equation and know what to do. Am I going to multiply? Do I have powers? What do I do with these negatives? Things like that. So here we're going to put 46 in here. But we know with that 1, we can rewrite it as 46. That means the same thing. This is the answer that Pearson's going to be looking for. All right. And this without that 1 power. All right, let's look at number 8. Well, now if you look at number 8 before you get started, you kind of look to see what's happening is that I have what's in the parentheses to a 0 power. So is it really necessary to take 6 times 7, because X is 7, 6 times 7 is 42, minus 1 is 41 to the 0. Does it really matter what's inside if it's to the 0 power? And it doesn't. The answer is 1. anything to the 0 power is 1. I could have been substituting in 7,000 in for x. 6 times 7,000 minus 1. It doesn't matter because anything to the 0 power is going to be 1. All righty. All right, let's look at number 9. Number 9 is a little tricky. And the reason it makes it tricky is because the parentheses O is not around the 2x. So the only thing that has a 0 power is the x. There is a difference between this statement and this statement, quite a bit. It's a big difference between those two. This is 1. It's just a flat 1. This, however, it's just the 2 has a power of 1 on it. The x has a power of 0. So it's just the x that has a 1. 2 times 1 is 2. Because remember in PEMDAS, you have parentheses, you do exponents, and then you multiply. So the exponent created a 1, and it's 2 times that, plus 9. And again, they're saying, okay, put in 4. Well, 4 to the 0 is 1. You're going to get a 1 no matter what you put in for the x. 4 to the 0 is 1. 2 times 1 is 2. Then 2 plus 9 is 11. All right, that's kind of a hard concept that, and we'll keep working on that here on number 10, and maybe some of the other assignments from your homework. But just remember, there's a difference between this and this, without the parentheses and with the parentheses. Power of 0 times the 2, because you do powers before you multiply. Now let's look at this one. Similar, you can go ahead and you could put in 13 in for the x. I didn't substitute it in, but we will here. Minus 2 to the first. And what that does, here we have to do the power before we multiply. Okay, I had to pause it for a second, so I had to kind of figure out where I was. So we put 13 in for the x, all right? And you do follow the PEMDAS because, you can combine. We don't have any x's, so we don't have to worry about like terms. But we do powers within the parentheses. And this is 4 times x to the 0. So you would do this first, which is a 1. 4 times 1 is 4. And 4 minus 2 is 2. You do the parentheses, 2 to the first is just a 2. All right, so, again, if you don't have the parentheses, it's just the x that has the 0 power. All right, now we're just going to turn this over, and we're going to look at a different idea that I haven't even really touched on yet. I'm looking for a clean sheet of paper. One moment, please. All right, so I found my paper. All right, what we're going to look at are negative exponents now. So we talked about a 1 is an exponent. We talked as a 0. What happens if you have an exponent of 0? It's just 1. And now negative exponents. What do you do with a negative exponent? In a negative exponent, it just means change the position. So here, x to the negative 3 means 1 over x cubed. So if you want to get rid of the negative, you change the position of the base. If it's in the numerator, it goes to the denominator. And when you do change the position, when you do change the position, you get rid of the negative sign. So these two statements mean the same thing. Now, what some people may try to do is they try to change the sign and make it a negative. So this negative has nothing to do with the sign on the answer. It has to do with the position of the answer. We'll look at this right here, 9 to the negative 1. Negative exponents can be rewritten as here without the negative, if you were to rewrite it with a positive exponent, change its position, it's in the numerator right now, it'll come down to the new denominator, and it would be a power of 1. So then you get rid of the negative when you change its position, or 1/9 would be correct. Before we talk about 13, I want to look at a couple of more examples. Let's say I have x to the -2. This might help for you to understand what's kind of going on. I want to rewrite this with positive exponents only. What happens, it's in the numerator, it will come down to the denominator, and when I do change the position from numerator to denominator, you get rid of the negative. This is in the denominator, it will come up to the numerator and become positive. These two, this fraction is the same as this one. This is written with negative exponents. This is written with positive exponents. A negative exponent means change the position. So here, if it's in the denominator, it comes up and becomes positive. If it's in the numerator, it comes down to the denominator and becomes positive. So when you do change the position, you get rid of the negative. All right, so if I had 1/3 to the -1, this is the same thing as 3 to the 1st. Means the same thing. All righty. So let's look at another example. I have a -y in parentheses. Parentheses matter. Not only does the y have a power of a -2, but also this -1 in front. Well, let's go ahead and we can change the position here. We can do that first. You know, you have choice in the order. You could square what's inside and then flip it, or you can flip this. All right, you change its position. Think of it as a flipping it, or you could flip it first and then square it. Let's go ahead and, okay. Notice that negative that I just took care of, this negative that I just did not change the sign. All right, it changed the position. It was in the numerator, now it's in the denominator. So I did that process, so I got rid of the negative because I did that process. Now I'm going to square what's inside. Because I have a negative, to an even power, the negative disappears. A -1 times a -1, that's what the squared means. -1 times a -1 is a +1. And then you multiply a power to a power. 1 times 2 is 2. So you end up with 1/y². All righty. If you wanted to, rather than take care of the negative, you move this, and then I squared what's inside. You could square what's inside. When you square the negative, it's a positive. When you square the y, 1 times 2 is y². And then you still have that -1 out there. And then you can just change its position. That's another way of looking at it. All righty. So here, I'm not sure, I don't know if I really gave you too many of those where you actually have to you have to remember that when you have an even, it's going to become a positive. A negative to an even becomes a positive. And then that negative flips it, and then you square it. Either order, you'll do fine. All right, let's keep working on this idea. So these aren't long, these problems don't take long. What about this? Write answers with positive exponents. Well, the B is going to come underneath, but the A stays because it has a +1 power to it. It's not in parentheses, so the -4 is only on the B. So this can be rewritten with positive exponents like that. This one, the 8 stays, the B comes underneath, changes position. The 1 stays, and this will come up. 1 times A is just the A to the 5th. So a negative exponent is just, flips it. You could think of it, almost like it's like a reciprocal. All right, and it doesn't change the sign. It's not a negative A to the 5th. It changes that exponent changes positions. Let's see what else. Okay, let's do some more. So here, this will come up. If I want to write it with positive exponents, the m cubed stays, it's already positive, that will come up. And you're done. Let's look at this one. The a squared stays. I'm going to draw my bar here. The a squared stays. This b comes underneath, and that c comes up to the first. Okay, and you're done. Let's look at 19. 19, I'm going to be changing the position. So I can do that on both of these since they're both in the parentheses. So the 6 will come up and the 7 will go down. That's what that negative means. Change the position on everything in the parentheses. Okay, I just took care of the negative. It changes the parentheses of everything in the parentheses. And then we square it. You square this and you square that. And there's your answer. So that negative kind of flipped it. The 6 comes up and the 7 goes down. And that's how you got rid of the negative exponent. And then I squared them. So I did, to me, it's a little easier to flip it or to change their position and then square it. All right. So that pretty much covers that idea. If you still have some questions, you're gonna let me know because I want to review some of the 10-2s with you real quick. Here's your examples of your assignments so that you can get used to how they may want their answers written. This is 10-2. Again, when you have a common base and you're multiplying, you add exponents. 4 plus 5 is 9. So your answer is 8 to the 9th. Type exponential notation with positive exponents. So we have a to the 9th is your answer because we want it written with exponential notation, which means they want an exponent in your answer. Let's look at your number 2. Type in exponential notation with positive exponents. Bases are the same. You add exponents. So these shouldn't take too long. None of these assignments should really take you very long. I tried to keep them pretty short. I just wanted you to have a general idea. Here, simplify your answer. Type in exponential notation with positive exponents. So here we will have z, cross my z's. We have 3 of them. 4 plus 6 plus 1 is 11. Z to the 11th as your answer. So don't forget, if it's not there, there's a 1. Here, we have a negative exponent. Well, what I'm going to go ahead and do is I'm going to add these together and see if the negative exponent will disappear. If it doesn't, I'll have to change its position. But we have a b. I'll take 23 plus a negative 4 and get 19. So then you're done. Your answer has positive exponents and it's an exponential notation. Okay. All right, now here, let's look at maybe number 8. Number 8 here. they want you to type with exponential notation. So what that means is they don't want you to write it as a number, as if you were to do it on your calculator. Type exponential notation with positive exponents. So we have 6 in the numerator. 7 minus 2 is 5. And leave it like that. That's exponential notation. You know, this one right here, kind of looking at this number 7, I can talk you through it. A to the 4th, A to the 1st gives you A to the 5th. B to the 4th, B to the 5th gives you B to the 9th. All right, so you just add with common bases. Let me see, I think that might be it. Let me look at this other page. You know, and again here, for some reason it keeps getting out of focus. On number 9, they want you to use positive exponents only because, you know, if you were to take 8 minus 10, you're going to get a -2. Or you just think of it as, all right, I'm going to put my x's in the denominator because there's more of them. This avoids having negative exponents. 10 minus 8 is 2. 1 over x squared is how you'd write that. Okay, now, let's look at number 13. Man, we almost did this entire assignment quite quickly. They want you to type exponential notation. So we're not going to have just a number here with positive exponents. All right, so I'm going to go ahead and I'm going to take a power to a power. I'm going to multiply. You have choices, and as you get into upper level mathematics, you have more ways of solving a problem. But we're going to go ahead and multiply those and get 10 to the -18. Well, they want it written with positive exponents. So this means change its position. It's in the numerator right now. So then it'll be 2 to the 18th. And that's your answer. Okay, it's written with positive exponents. But now if you look at 14, a power to a power, when you multiply those, you get 18, positive 18. So how do they want your answer? Type your answer using exponential notation. There's your answer. All righty. 15, t cannot be 0 because you can't have a 0 in the denominator. I'll say, well, it's not in the denominator right now, but it will be. A power to a power you multiply. So we're going to combine a couple of ideas here. But they want it written with positive exponents. So I have to, right now it's in the numerator. I have to move it to the denominator to get rid of that negative. It changes its position. For if it's negative here, it's positive underneath. If it's negative underneath, it'll be positive in the numerator. Change its position to get rid of that negative. Here's your answer. T cannot be 0 because you cannot have a t in the denominator. That's why they told that to you. It's not that you needed that to solve it. They just told that to you. All right. Okay. I think that might be pretty good for this. All right. Let me look here. No, I think so. I think you guys are pretty good. And again, if you have any problems, just let me know. I think this video is long enough, but it covered the 2 sections. One more video and for 10.4, and we'll look at that after a bit. All right, let me know if you have questions, guys. Getting close to the end. Bye-bye.